Hey everyone, welcome back to my number sense series. In this video, we're going to talk about repeating decimals to fractions part 2. So you might remember in the last video, we talked about repeating decimals, but we didn't talk about every kind of repeating decimal. We only talked about what I call a pure repeating decimal, where every single digit repeats. For example, 0.13131313. Every digit repeats there. But what if we have something like 0.166666666? The 1 never repeats, but the 6 does. And now this is definitely different from the last one, because whereas in the last one we could just say it's this over 999, here we can't do that because one of these doesn't repeat. So when we do our proof, we have to take that into account. So how can we tackle a number like this? Well, first of all, if you remember what we did a few videos ago, you might recognize this as just 1 over 6. And if you do that, you could just write down 1 over 6. But what if you can't do that? Let's prove it. Let x equal 0.1666 repeating. Now, what we want is the same as in the previous video. We want all the infinite digits to cancel out. But here, instead of every infinite digit behind the decimal point, we have a 1 also. So how can we get that 1 out? Well, we can just multiply by 10, right? If we multiply by 10, then we'll have 1.666, and every infinite digit is now behind the decimal point, and only infinite digits are behind the decimal point. And so now if we subtract, we'll get like a nice integer, and this will be very easy. How can we get more repeating 6s? Well, we can multiply by 10, but we can also just multiply by 100, right? We can just multiply again. So we'll get 100x equals 16.66666. And now we see that this is going to cancel out very, very nicely, because if we just subtract these, we'll get 90x equals 15. And so x equals 15 over 90. 15 over 90, you can see, oh, the top and bottom are both divisible by 3. So that would be 5 over 30, which is 1 over 6, as we said before. So you'll see the process for doing this is a little bit more complicated as it was before. But really, if you understand the idea, it is super, super easy still. The only thing is, here in the bottom, it's not a 99 anymore. It's a 90, right? So how can we determine what it's going to be if it's not just 9s every single time? Is it going to be 90, 900, 9,000? Let's find out. Here we have 0.2787878. So once again, we have one non-repeating digit, and then 2 repeating digits. So how can we handle this? Well, it's going to be a very similar idea. If we want only infinite digits behind the decimal point, what we can do is multiply this by 10. And we'll have 10x equals 2.7878, etc. Okay, but what if we multiply by this by 10 again? We'll get 100x. Well, we'll get 100x equals 27.8787, and we have 8787 instead of 7878, and that doesn't cancel out at all. So what we can do instead is multiply by 1,000. And if we multiply by 1,000, you'll see we get this 78 out here, and we'll have more 787878 instead of 878787, and that's going to cancel. So we'll have 278.7878, and then we can do our subtraction. And when we do our subtraction, it's going to give us 990x equals 276. And now we can divide, right? X equals 276 over 990. Now we can notice that the top and bottom are both divisible by 2, and they're also divisible by 3. And when you divide 2 and 3 into the top and bottom, what you're going to get is 46 over 165 as your answer. Now the important thing here is to look at the denominator. Here we have 990, so it's not 900 as we might have thought previously. Okay, so what if it's just 990, 9990, 99990? Could it be like that? Let's find out. In our next question, we have 0.2188888. Now, here I don't have a bar, but still, when you see this 888 ellipses, you should assume that it is just going to be 8s forever. So, once again, we're going to set x equals this, just like I should have done over here. So we're going to have, now how can we get these only 8s behind the decimal point? Well, we have to move this 2 and 1 over, right? So we should multiply this by 100. So here we can have 100x equals 21.888, etc. Then, if I want to get more of just 8s, I'll multiply by 1,000, and I'll have 1,000x equals 218.888. And once again, you can see that these are going to cancel very nicely. So if we subtract the top and bottom, what we're going to get is 900x equals 197, or x equals 197 over 900. And no simplification here, that's it. All right, this time our denominator was 900. Well, it's been 90 before, it's been 990, and it's been 900. So clearly, we can't tell what it is super easily. There's no super easy pattern, but there is still an easy pattern. And what the pattern is dependent on is actually how many digits are repeating and how many digits are not repeating. Notice here, when we have 90, what did we have? We had one repeating digit and one non-repeating digit. It might look like we have two repeating digits, but it's actually just 6. So we can write it as 0.16 repeating, and that is the more proper form. So we have one repeating and one non-repeating, okay? Notice that here we have 990, so 2 9s and 1 0. And what do we have? We have 2 repeating and 1 non-repeating. Here, when we have 900, so 1 9 and 2 zeros, what we have is 1 repeating and 2 non-repeating. So it looks like it should be that the number of 9s in the denominator corresponds to the number of repeating digits, and the number of zeros corresponds to the number of non-repeating digits. And in fact, this is the pattern. But now, what's the top? Well, clearly the top isn't going to be just 2 and 8. It's not going to be 16. It's not going to be 278, right? It's 276. It's 197. It's 15. So how can we determine what the top is? Well, notice how we determine the numerator in our derivations, okay? In order to get 15, we have to do 16 minus 1. In order to get 276, we have to do 278 minus 2. In order to get 197, we have to do 218 minus 21. What's going on here? We're taking what we think of as the whole number. So the number that you get from combining the non-repeating digits and the repeating digits. And from that, we are subtracting the number that is made up by the non-repeating digits. For example, here we have 2, 1 are the non-repeating digits. 8 is the repeating digit. When we combine them, we get 218. But how do we get 197? It's 218 minus 2, 1. 2, 1 is the non-repeating part, so we subtract that. Notice here, 1 is the non-repeating part, so we do 16 minus 1. 2 is the non-repeating part, so it's 278 minus 2. That is the numerator of our fraction. So, just to summarize, the numerator of the fraction is going to be the number that is made up of both the non-repeating part and the repeating part. So here, 278 minus the number that is made up by just the non-repeating part. So for example, 2. So we would do 278 minus 2. We would do 218 minus 21. And that would be our numerator. Our denominator is a number where you have some number of 9s and then some number of zeros. The number of 9s is equal to the number of repeating digits that you have. For example, here we have 7 and 8 repeating, so we're going to write 99. And then we have 2 non-repeating, that's 1 digit, so we have 990. So here we have 276 over 990. If that is a little bit too complicated right now, let's just do a bit more practice and hopefully you can see what's going on. So 0.42, let's use our trick. 0.42, so okay, what's our numerator of the fraction going to be? It's going to be, remember, the whole number, so like 42 minus the non-repeating part. 42 minus 4 is going to be 38. And the bottom is going to be a number of 9s and zeros, right? How many 9s do we have? Well, we have 1 repeating digit, so we should have 1 9. And we have 1 non-repeating digit, so we should have 1 0. So we'll have 38 over 90 or 19 over 45. But this is the important part. 38 over 90 is the important part. And if you don't understand this, let me just derive it for you once again. If we have x equals 0.42, 22222 that is, we multiply this by 10. So we have 10x equals 4.22222. We multiply it by 100, we have 100x equals 42.22222. Then when we subtract these two, you should see what happens over here. When we subtract these two, we get 90x equals 42.222 repeating minus 4.222 repeating. That's 42 minus 4 equals 38. And then once again, we just divide both sides by 90 and we have 38 over 90 or 19 over 45. But hopefully you see here how we are getting to 38 and 90, right? It's 100 minus 10. It's 42 minus 4. That is where we get 38 over 90. Even though that's not the answer, that is the important part of this lesson. Last question, 0.583333 repeating. Once again, we can just use our formula. So it's going to be 583, which is the, quote, whole number. 583 minus 58 over, what is our number? We have one repeating digit, so we should have 1 9. We have two non-repeating digits, so we should have 2 zeros. So it's this number over 900. So what is this top number? It's going to be 525 over 900. Now, we can simplify this, of course, but it's a little bit difficult to recognize how to simplify this. But the important thing that you might want to recognize is 525. It ends in a 2-5. So if you remember, way back then, our video on how to multiply by 25, anything that ends in 2-5 is a multiple of 25. And 900 is a multiple of 100. And so thus it's a multiple of 25. So if you divide the numerator and the denominator by 25, what we're going to get is 21 over 36, or 7 over 12. And 7 over 12 is a very simple fraction. And so there's actually another way to do this question. One that is not necessarily one that you can use all the time, but if the fraction is simple, if you recognize it, this can be very easy. Watch this. 0.583. Well, that's really just 0.5 plus 0.083 repeating, right? Well, 0.5, that's just 1/2. 1/2 plus, and if you know your fractions, you can recognize 0.083333 as 1 over 12. That is the really important part. So now this actually just turns into fraction addition, and it's 1 over 2 plus 1 over 12, which is of course 7 over 12. And something a little bit similar is going on over here. 218888. That you might be able to recognize as 21.88888 over 100. And you can write 21.88888. If you recognize 0.88888 as 8 over 9, you can write this as 21 and 8/9 over 100. Then when you turn 21 and 8/9 into a mixed fraction, what you get is 197 over 9. 197 over 9, then over 100 is 197 over 900. So hopefully you can see that all of these derivations, they lead to the same thing. And there's a lot of ways to think about this. But of course, the one I would recommend is the one where you take the whole number, subtract the non-repeating part, and then put it over a bunch of 9s and 0s. So that is going to be generalizing our understanding of repeating decimals. Hopefully this video is not too hard. If you understand the derivation, it's going to be super easy to memorize the rule. And even if you don't understand the derivation, you can memorize it anyways. And that's the important part, that you get the answer on the paper and it's correct. So I hope this video was really helpful to you guys. Thank you guys for watching, and I'll see you next time.